Let's discuss solvay process. Solvay process. Solvay process is one of the complex industrial processes, and so it has so many chemical processes. Let's start with step one. Step one is the introduction of ammonia from Haber process. So you must know the source of ammonia is from Haber process. And there is also brine. Brine is concentrated sodium chloride from electrolysis of concentrated sodium chloride. The mixture form ammoniated brine, or ammonia called brine. Ammoniated brine that we pass to the solvay tower. Solvay tower is fixed with baffles to increase surface area of contact during the process. Solvay tower, we also introduce CO2 from kiln. That is another chamber of combustion, of decomposition of calcium carbonate, which is limestone, and coke, which is carbon, right? So we also introduce water because we need water for the formation of the products. So at the kiln, we have calcium being decomposed to form calcium oxide plus CO2. So calcium oxide, the other name is quicklime. So quicklime is passed down, and CO2 is passed to the solvay process, solvay tower. Here we have the formation of sodium hydrogen carbonate and ammonium chloride. So you can mix all the raw material in the solvay tower, that is ammonia plus sodium chloride plus water plus CO2 to give sodium hydrogen carbonate plus ammonia chloride. Is that okay? Now, ammonia chloride, you must know two things here. You must know the state of sodium hydrogen carbonate is solid, and then ammonia is liquid, because this takes time before it forms solid. So it will be still in solid state. So you can take them through the process of filtration, where we are going to filter out sodium hydrogen carbonate, right? So we're going to pass what? Ammonium chloride to ammonia regenerator on ammonia recovery tower, and then we pass sodium hydrogen carbonate to furnace, right? For what? Decomposition. So we are decomposing sodium hydrogen carbonate to form sodium carbonate, water, and CO2, which will recycle back. So here we have this quicklime. We select it to form slaked lime. Slaking simply adding water. So slaked lime is formed, which is now taken to the ammonia regenerator. So that slaked lime is calcium hydroxide. Is that okay? So in the ammonia recovery tower, we are going to mix what? Ammonium chloride plus slaked lime, which is calcium hydroxide. Is that okay? To form calcium chloride, water, and CO2. You have to balance and make it as a stoichiometric equation by giving the correct state symbols and chemical symbols. So here we have calcium chloride, which is red mud, solid calcium chloride, which is the only byproduct of solvay process. So if you are asked, the byproduct of solvay process is calcium chloride. It's a red mud used for de-icing in temperate regions. It is used for sodium metal extraction because it lowers the melting point of the sodium. It is also used as a drying agent for gases in the form of anhydrous what? Anhydrous calcium chloride. You must indicate that. That is the form in which it is used. So here we have ammonia taken back. Is recycled. And we also have water taken back. Water is also taken back. And what again? Ammonia chloride, ammonia, sodium, that is ammonia, calcium chloride, and water. So ammonia is taken back and water. And from the decomposition of sodium hydrogen carbonate, CO2 is taken back and water, right? So those are recycled products. Recycled products, we have CO2, water, and ammonia. Is that okay? So what you must know is the sources of the raw materials, and you should also know the recycled products and the byproduct, and the main product is always sodium carbonate, sodas. Uses: manufacture of what? Manufacture of glasses. Next, cement is a component of cement, manufacture of cement. Soap and detergent. Detergents. Or softening, add water. Softening, add water. And I also a component of food additive like baking powder. Is that okay? What again? So the process at the kiln is decomposition, all right? Process at the furnace, decomposition. And here, filtration. And if you are asked to explain that process of filtration, then you must know that ammonium chloride is in liquid form, and ammonium hydrogen carbonate is in solid form. So you're going to filter out sodium hydrogen carbonate, right? And then you heat it to form sodium carbonate. Sodium carbonate is thermally stable. It will remain in the solid form. So raw materials: brine, ammonia, and limestone. Any question? Is that okay?